Welcome to lesson 3 of our revision course, and on this lesson we are going to be talking about momentum and impulse. And I'm just going to rush through our learning objectives. Is that at least by the end of this video you should be able to do a number of things. You should be able to state Newton's second law in terms of momentum, and you should also be able to use the impulse momentum theorem in calculations, and you should also be define the term impulse. So all of this will be explained in the video. So Newton's second law in mathematical terms is given by F net, and you should remember this from early in the year. I'm sure you did it in class. Is the product of mass and acceleration. So now, how does this law, which is Newton's second law, relate to momentum? Well, we can rewrite this law in terms of momentum, and you will see how we do that. Okay, so we know that acceleration is given by the change in v divided by the change in t. So it's velocity, the rate of velocity. So we can do that, say, okay, F net then becomes m change in v, which is equals to a change in t. But we know that a change in v is nothing but final velocity minus initial velocity. So again, we go back to our equation and we substitute that there. You see that now. Then we have F net, which is F net is nothing equals to m Vf minus Vi, which is over the total, which is over the change in t. So if you look at this, if you look at these two equations, where F net, it says it is m change in V over a change in t, which is nothing but you realize that this is actually a change in momentum. So meaning, remember we did say that the change in P is m Vf minus Vi. So meaning this equation can actually be written as change in P over change in T. So now what we have done is that we have now written Newton's second law of motion in terms of momentum. But what does it mean? So this equation over here, F net equals to a change in P divided by a change in T, means that the net or resultant force acting on an object is equal to the rate of change of momentum. So you should know that definition. You should be able to define Newton's second law using in terms of momentum. So the second thing that I want us to talk about is the fact that this F net here, so F net is directly proportional to momentum. So if the momentum of the system increases, the total net force will also increase. If it decreases, the total net force will also decrease. But F net is inversely proportional to a change in T, meaning if the time or if the time of contact or the time of that collision increases, the total net force will increase, and then if the time decreases, the total net force will increase. So that's an important thing to know, that F net is directly proportional to the change in momentum but inversely proportional to the change in time. But also we can go a step further and describe something which is called impulse. So what is impulse? You need to know the definition of impulse. Impulse can be defined as the product of the net force and the time interval for which the force acts. So remember, we have our Newton's second law in terms of momentum, and it's given by this equation. So the product of So when you multiply the net force and the time interval, we get something which is called impulse. So to do that, we can simply cross multiply. So F net times change in t multiplied by a change in t equals to a change in p. So, and this entire thing, we call it impulse. So you will note that impulse is equals to the change in momentum. But now, let us do a question so that this whole thing can make sense and it can actually stick in our heads. So we have a question over here and it says a 150 Newton resultant force acts on a 300 kg trailer. Calculate how long it takes this force to change the trailer's velocity from 2 meters per second to 6 meters per second in the same direction of motion of the trailer. So take a moment to just write down the question. And then the question continues to say, assume that the forces act to the right, which is the direction of motion of the trailer. So now we have to find, what are we calculating? So we have to calculate how long it takes. Let me just underline that, to the right. And yeah. So how do we solve this? So the first thing will always be direction. So let us say to the right is positive, and then to the left is negative. It's important to indicate that. And then another thing that I would like to do is just to draw. So let's say this is the trailer, and then this is the force. And they said that force equals to F equals to, it will be F net equals to 150 newtons. And it's pushing this trailer. So initially this trailer was moving at a velocity of VI, initial velocity of 2 meters per second. Then after a certain time, this trailer will now be moving at a velocity of 6 meters per second because of this force there that is acting on it. So we've done the direction. We've chosen direction, right, positive, left, negative. We've drawn the schematic, and then now it is just to list what is it that we given, what is it that we know. We know that F net equals to 150 newtons. The mass, which is M, is given by 300 kg. Initial velocity is given by 2 meters per second. Final velocity is given by 6 meters per second. All of them to the right, so hence all of them are positive because forces are also vector quantities. Awesome. So now we have to remember that equation that says the change. I'm lying. It's not change, it's just F net. That says that F net, let me just draw a line here, F net equals to a change in P over a change in T. So this is just Newton's second law in terms of momentum. And we know that we can rewrite change in P as M Vf minus Vi. Initial velocity, final velocity minus initial velocity, all of it divided by a change in T. Then you look at your equation. What do you have? I have F net, I have the mass of the trailer, I have the final velocity, I have the initial velocity, and this is what I'm looking for. So I want to make this subject of my formula. This means I have to cross multiply both sides. So changing T multiplied by F net, which will give us no. So yes, and then this will come to the bottom and this will come to the top. So it's just a quick calculation. So we end up having that the change in T is actually going to be M Vf minus Vi, which is equals to F net. If you don't understand how this is done, you can just let me know. it wasn't cross multiplication. You just take this one and then here, let me rephrase that. So you take this thing, change in t, multiply by f net, and then you also again going to divide by f net. So when you divide by f net comes to the bottom, and then this was just 1 multiplied by m, 1 multiplied by the change in momentum, which remains as the change in momentum. So we have everything. Let us just put everything into calculation. Our mass is 300 kg. Vf is, our final velocity is 6 minus 2 divided by f net is nothing but 150. And if you put this in your calculator, you should come with an answer of about 8 seconds. So put it in your calculator, and so that you can see that the answer is 8 seconds. So what does that mean? So that means that this force, so therefore the force of 150 acts on the trailer for 8 seconds to change that velocity. To change, I don't have space anymore, to change that velocity from 2 meters per second to 6 meters per second. So yes, I think this brings us to the end of this lesson. And yes, remember, questions, if you have any questions, you can always just ask me on WhatsApp.